So hey, everyone, welcome in this session on Azure loves Terraform and Terraform loves Azure. The main goal of this session is helping you a little bit in understanding Terraform, how you could use it as maybe a better way or an easier way to deploy your Azure resources. And for me, I started using Terraform about 2 years ago because I really looked into an easier language and an easier way to deploy my Azure backends. But it's mainly about the language, but I'll talk about it later on, obviously. So a couple of topics that I want to cover just to give it some structure is starting with ARM templates. And I'm pretty sure that you're all familiar with ARM templates, so it shouldn't be that hard, but it's quite important to emphasize some characteristics of an ARM template and use that as a segue to discuss Terraform. And then next I'll talk about what Terraform is and how you could use it in the Terraform basics, walking you through a couple of live demos. And then talking how the two worlds like Terraform concepts and Azure concepts are coming together, and closing with another demo on Terraform in Azure DevOps. So when we look at ARM templates and how you use it, it's mapping with the concept of infrastructure as code, which means that it allows you to manage and deploy your infrastructure components in a public cloud or even in your on-prem data center using a descriptive model. So what you're going to do is creating a definition file in which you define this is what my storage should look like, this is what my networking should look like, my servers, but it's not only infrastructure. You can deploy web apps, databases, and other cloud services or on-prem services with it as well. Now, the other characteristic about infrastructure as code is that it's idempotent, which means that once you have your skeleton file and you test it out and it runs okay, that every single time you're going to redeploy the file in the same environment or in a different environment, it's always going to produce the same result. And then immutable and lights out means that it allows you for end-to-end automated deployments. So it starts with creating your definition file. So ARM templates using JSON, you all know this. And from there, you're going to inject your intelligence. So you come up with a specific version. In my example, typically takes me about 5 attempts before my template is actually working fine. So that's where I end up in version 0.5. And I'm going to test it out against some specific resource group. And from there, when everything is working fine, I'm going to make some changes, ending up in version 6. And why not moving it into a different environment? And then eventually we end up in a final 1.0 version that we're going to deploy in a different resource group again, and adding some updates, making some changes, and moving to a full production state. Now, when you look at ARM templates in general, it comes with a few challenges, where the first one, and I think it's valid for all of us, is that the language is complex. So it's based on JSON, where even JSON as the syntax outside of the ARM complexity is already painful to understand and hard to read. That it's quite complex in structure. So you need to come up with the Azure resource providers. You need to come up with the exact order, how you want to deploy them. You also need to think about any dependencies. So if you want to deploy a virtual machine, you need to tell the JSON file what the dependencies are on storage and networking. So again, another point that is heavily frustrating, at least for me, and quite painful to go through. Then the authoring process itself is also hard and most of the time quite frustrating. And it's just because there's no real easy tool to use. And you got Visual Studio, but the GUI snipping is still the same from 2015. So a lot of it is just missing. And we do have the quick start templates on GitHub, but half of the time they're not always working anymore, and some other complexity that comes with it. Then another one that I was missing a lot is not having the capability of adding comments. So you just have the template file, but it's quite hard to find out what a template is actually doing. And I know in meantime, but only recently, they made it possible to add comments into an ARM template, but then also finding out that you could deploy a comment-based template file using CLI or PowerShell. But if you try to upload it into the portal and deploying from there, it would fail and telling you that the syntax is not correct. Then from a testing perspective, you literally need to run the deployment itself to validate your deployment state. So if something is wrong in the definition, or you try to target a service or even specific parameters or variable information like a storage account name that's not unique or not using the correct naming conventions, you're only going to find out during the actual deployment. And then you go back to the template file, making some changes and redeploying it. And if you already succeed in deploying it, then every now and then it fails, like the same example, storage account name is incorrect, or the DNS name for a public IP is not available. And if that happens all the way at the end of your deployment, then the parts that deployed successfully are there, but it's not going to undo the deployment, and technically the deployment fails. And there's also no delete option. So once the deployment is fired off, it just runs and hopefully everything gets completed fine. And it's Azure native. Now that's obviously a benefit. But on the other side, there's quite a lot of organizations not just using Azure. So it means that in an easy example, if they're using Azure today, they're going to use ARM templates. If they use AWS, like I think about half of our typical customers that we see out of the ATT deliveries are not just using Azure. So it means that besides becoming really good in ARM templates, they also need to become really good in AWS CloudFormation, or if they're using Google, it's the same idea, but it's using a different language again. And knowing that quite a lot of those customers are multi-cloud today or having a multi-cloud strategy, it's not really going to help them. And the other challenges that I talked about in ARM, at least challenges for me, are not really helping them either. And that's what Terraform is trying to help with a little bit. So first of all, what is Terraform? It's a product from a company called HashiCorp. And in meantime, they came up with a couple of other technologies that I'm showing here on the upper right. I don't use all of them myself, but so Terraform, what I'll talk about later on, is an infrastructure as code concept that allows you to deploy assets in a cloud or on-prem environment. Then HashiCorp Vault is a little bit similar to what Key Vault is doing for Azure. So it's a centralized cloud service out of HashiCorp that allows you to store secrets. So obviously, instead of storing your secrets hard-coded in the template file, you want to move them somewhere out, and you could use Key Vault for that, but technically HashiCorp is also offering a similar solution themselves. Consul, Nomad, Vagrant, never used those myself, but what they're trying to do is moving towards a multi-cloud orchestrator, and integrating with Kubernetes, for example, is a big one. So what Consul allows you to do is using it as some kind of orchestration tool across multiple platforms. Like Kubernetes, you could manage them in different cloud environments and not even using Kubernetes command line tools, but using it from Consul. So I never used it, but I think it's a bit like our Azure Arc offering that allows you to manage multi-environments. And then Packer, some of you who delivered the 204 might recognize it. It's a virtual machine image tool. So you could start from the marketplace fresh operating system image and adding some customizations into it and storing the final image output back into the Azure Virtual Machine image library. And that's what a Packer is doing. So in their own definition, it's a product allowing for provisioning infrastructure application. So it's infrastructure as code together with configuration as code, and it's multi-cloud aware. So you could use Terraform against VMware, against Hyper-V, using it for Azure, obviously, AWS, Google Cloud. So that's where the multi-cloud strategy comes from. And that's quite obvious. And next to that, it's relying on its own language. So HashiCorp, as the company, came up with HashiCorp configuration language. It's based on Golang, and the syntax is a lot easier than what we have in Azure templates, but also in, for example, CloudFormation templates. And the core, similar to ARM templates, is infrastructure as code, but it also allows you to do some more intelligence, adding configuration settings and whatnot. Now you know what Terraform is, at least a little bit. The next question is, why should I use it? And some of my examples should already make it a little bit clear. So first of all, the HashiCorp configuration language is almost like plain English. So it's a lot more natural. It's not as complex. It's far from being complex as JSON that we use in ARM templates. Funny enough, it also results in faster deployments. And I never really clocked it myself, but I find out, and hopefully I can show you in some demos, that once you run your Terraform deployment, that it's immediately targeting the Azure platform. And somehow the deployments are running faster, where in a full production environment, I'm pretty sure it's not all that important if your deployment kicks off within 10 seconds or within 3 seconds. But in the end, it somehow could make a difference. And then something that I'll talk about a little bit later on as well is the Terraform state file, where the state file is keeping track and it's creating like a snapshot of an actual running or already ran deployment. And it also provides a destroy option, where if a deployment is failing, you could instruct it automatically or manually to destroy the failed deployment. So something that an ARM template, for example, is not even understanding. So a screenshot, but I'll show you some live templates that I'll use later on. But if you look at a syntax just for creating like an Azure storage account, on the left-hand side, it's the syntax to deploy or define the Azure ARM template structure, and doing the same in Terraform HashiCorp language is about 50% shorter in code. Now, it's not about how many lines of code you have in your template, but I think it should already show you that the language is a lot easier. And next to that, it's a lot more efficient. And I got a few sample template files that you can reuse later on yourself. So first one is quite straightforward. The first part is your service principal. So you got a couple of different ways to interact with the Azure platform, but the easiest one and probably the recommended one is using service principal. So once you have your service principal, AZ, AD, SP, create for RBAC, that would be the Azure CLI command line option. You copy that information into your template file, and from there you run your deployment. Where the second part here is create a resource group. So the first thing that is quite interesting is adding comments. And next to that, it's a quite easy structure. You're going to deploy the resource, in this case called resource group, where even for a long time, as long as I remember, Terraform allowed you to deploy the resource group as well, where ARM templates only offered that capability like a few months ago. And next, you're going to define your deployment itself. So the hello Terraform in this case is just the name of the deployment. And next, and that's obviously where you need to use your Azure skills, knowing that in order to create a resource group, you need to specify the name and the location. But this is just a resource group. So let me open up another example that's a bit more complete. So the first part, we're doing the same thing. So we define some variables, your service principals, and there's some other concepts on how to use your credentials. Where next, the first part is again the resource group, but it also understands tagging. So from here, you can add tags into your deployments that get flagged into your resources as well. And from there, we move on with creating a virtual network, a subnet, some network security groups, public IPs. But even just quickly looking at how the syntax is built up, anyone could probably understand what this template is doing. And even without looking at all the details, just using the commands, you know that this part is a snippet of code that allows you to create a public IP. And a little bit more down, it's allowing you to create network interface and so on and so on. So quite easy from a language perspective. So that's the template definition. So from here, the next step is obviously how can we deploy it? So Terraform by itself is, I would say, not doing anything. It's relying on Terraform providers. And those are typically reusing information from Terraform itself, but also built in combination with the actual cloud backend. So Terraform is your deployment engine. And from there, if you want to target the Azure platform, you're going to use the Azure provider. If you want to communicate with Kubernetes, no matter where it's running, you're going to use Kubernetes provider, AWS provider, and any other ones like, again, on-prem, VMware, Hyper-V, and a lot of different ones. So that's really the baseline where the intelligence comes from. Then back to the syntax, where I found another example that's interesting to see on how you can easily reuse your templates for the multi-cloud component they offer. Now, one misconception that I hear quite a lot in the field is that customers, once you start talking about ARM templates and how they use them, how they author them, and they start talking about Terraform, the misconception is that they only need to create a template once, no matter what cloud provider they're targeting. But in reality, you still need to create multiple template files. So like in this case, if I want to target a network, I think, yep, this is a virtual network in the Azure backend, and I want to do the same on the AWS backend, then I still need to come up with two different files. But the syntax even here is quite straightforward and very much aligned with each other. So the first part is where you're going to identify and specify what provider you want to use. So this is defining what cloud backend or on-prem private cloud backend you want to use. Where next you're going to specify variables, maybe parameters as well, and defining the actual structure. Now, if you look at provider, left and right, technically you could just do find replace Azure RM with AWS, and hopefully for us the other way around. The definition of variables is relying on the actual cloud environment. So in Azure, we talk about VNets, where in AWS, we talk about VPC. And even there, it's almost find replace, like VNet with VPC, and it's going to work fine. Then you got a data portion. That's where you define some parameters and deployment settings. And lastly, the actual resources themselves is obviously depending on the cloud backend. But depending a bit on what you're deploying, how complex your deployment itself looks like, they claim a statement that 85 to 90% of the syntax is identical, no matter what cloud provider you're using. And yesterday in the other session was a question around some kind of transforming tool or a translation tool from one environment to the other. It's not something that I'm aware of, but if it's quite easy and you know the terminology where VPC maps with VNets and virtual network settings maps with subnets and anything, it technically would be doable, but I don't know about any such tool. But in short, for running your deployment, so you start with defining the resource type, and that's identifying the required provider. And actually also nice is that you can mix providers in the same template. So you could come up with a snippet of code that's targeting your Azure backend, and at the same time in the same template using an AWS or any other environment snippet of code, and that's targeting the two environments. So the basic is defining the resource type. So in this example, I'm using the resource group, literally what I showed you in that first demo file. Next, you're going to specify the deployment name, and the demo RG here is a little bit confusing. And then last, you're going to specify the resource configuration. So for each and every building block, it's typically 4, 5, maybe 10 lines of code for that one little resource. And that's it. So quite easy to read, quite easy to actually build. And then once you have your Terraform template files ready, you're going to run your deployment, obviously. And that's where the real intelligence from Terraform comes in, where it starts with initialization step. And that's where it's going to recognize your cloud target or environment target. So if you define resource provider Azure RM, it's going to download the Terraform Azure resource provider to your local machine, and from there reusing it. It's also going to validate the syntax of the template file already. So whenever something is wrong, like if you would build the ARM template and you're going to run the PowerShell CLI script, it's not going to tell you if it's correct from a syntax perspective or not. And it's only when you fire off the actual deployment that it's going to tell you. So Terraform is helping you and validating all that upfront. Then in the Terraform plan process, you're going to run a pre-flight validation. So that's where it's going to map the different resources that you want to deploy. And it's also validating if you already have them running on Azure, for example. Then the actual deployment itself, where the resources get created, is requiring Terraform apply step. And before you're going to run it, you need to confirm, unless you open up your auto confirmation settings. And lastly, whenever something goes wrong during a deployment or when a deployment is already completed, you could also use Terraform to actually clean up your environment and destroy resources, including full resource groups. So 4 different steps, and that's literally all it takes. And you could play with it a little bit. So even if you don't run the init and the plan pre-flight, and you just pick up a template file, you run apply, it's always going through the other 2 stages as well. So always coming back to that initialization and telling you this is the Azure resource provider or any other provider version that you're going to use. And I'll show you a demo later on, but just repeating the 3 steps, and then I can combine the 3 steps back to back. Then Terraform plan, where it's going to read out, this is what you want to deploy, and this is what I already detect in your environment. And then lastly, running Terraform apply, and that's where you're going to build up your environment backend. So one thing I didn't tell you yet is what you actually need to execute to run Terraform. And it's quite straightforward. So the only thing you need is a terraform.exe on Windows. So this is the program, the product, and that's all it takes. Everything else, so a couple of zip files are my sample scripts and the demo folders that I'm going to use for my template files. So if I use the first one, so I'm going to do Terraform init. Where the other nice thing is that I don't need to define the explicit deployment file that I want to use, but I could just target the subfolder or the directory that contains my Terraform files. So remember the first one, just creating that resource group, it's in the demo samples folder. So it's going to scan the folder, detecting the Terraform files and picking up the information. So since I was targeting the Azure RM _ resource group as the resource type, it knows that now it needs the Azure RM provider. Similar a little bit to our own ARM deployment approach, it comes with versioning. So this version 1.37 is the specific version for Azure RM. And similar to ARM, every now and then you need to update the APIs or even the schema of the ARM template, where for a long time it was pointing to 2015, and recently it changed to 2019-05-01, I think. So obviously, whenever the Azure backend is changing, the Azure resource provider for Terraform also comes with a new version. And then the provider random, it's picking up some generic Terraform information from here, but that's showing you that it's doable to mix different providers in the same template file. So the second one is Terraform plan. And that's where it's literally going to read out the information from your template file. So this is a validation of your deployment file and picking it up. Now, although I told you that in my demo samples folder, I only have the syntax in my template to deploy the resource group, it's recognizing a lot more. And it's going to try to add and remove some stuff. And that's what I talked about briefly before, the Terraform state file. So what it does whenever you run a deployment, it's going to capture the intelligence, it's going to capture that information and store it in, not really in memory, but literally validating. So what happens here is, based on some demos I did yesterday, it's going to recognize that I need to add a new resource group. And it means that in my previous deployment, I didn't have one, but it's also going to remove some components from the same template deployment called Hello Terraform that I ran yesterday. So from here, imagine that you detect like, oops, I was using the wrong template, because I do not just want to run a resource group creation, but I want to deploy everything, which means I'm going to plan a new deployment where now I'm picking up the correct template folder. That's the one I showed you with the full virtual machine state in there. So it's going to scan the file, mapping it with the Terraform state, and again highlighting what's going to happen. So this is the full syntax, the full description about what Terraform is going to do. And similar as the previous example, if I go up a little bit, it's going to identify all the settings, all the parameters from your deployment. It's highlighting a green plus sign for any change or any new resource getting created. And the minus red is deleting one. So all looks fine. And all the way at the end, it tells you I'm planning to add 8 resources, so like creating new ones. Since I didn't have a previous deployment already available, it's not going to change anything, and it's not going to destroy anything. And last, we're going to run Terraform apply, and that's firing off my deployment. So I give it a few seconds, and if all goes fine, deployment is getting validated. Now from here, quite important, it's going to ask me for confirmation. You could add a setting, auto approve, and then obviously it's not going to wait. And from here, within a split second, the deployment is already running. So I'm not going to wait for that one. It's just deploying Azure resources, so should be quite straightforward. So back to the Terraform state file, and that's really, I would say, the intelligence around the Terraform deployments. So based on each and every deployment name you specify, it's going to create a Terraform state file, where the state file is literally a snapshot, like the output of an already ran deployment. Now you could come up with a scenario where you've been using Azure for quite a while, deployments have been happening, and let's say from tomorrow on, you start using Terraform. Then obviously Terraform itself, the first time, has no clue about your state. And that's where you could also use Terraform import. And that's going to build up a state file based on the actual deployments in an Azure subscription or based on an Azure resource group, and reusing the actual present state of your running Azure environment as a starting point for detecting updates. And showing you what a state file looks like. I did it a little bit wrong in my demo environment here, because my Terraform state file is stored in the root of Terraform, where technically you would fire off the deployments from within, like the demo samples or demo samples2 subfolder, and storing the state file in there. But nothing's blocking you from using it in that way. And the output is a JSON file, so it's not as easy to read as the actual template, but it's a capture of your actual deployment that happened before. And some customers are also using this to build up documentation. Although there's using the command option, there's more details in the template file than in the actual state file. But again, when you run your Terraform init and Terraform plan using the same deployment name, it's going to check if there's any state file for the same deployment name and validating all the settings. And all that could happen without actually targeting the Azure platform. So that's a bit on Terraform by itself, a little bit on ARM templates all the way in the beginning. And where it becomes really cool is where you're going to combine the two worlds together. And combining works in a couple of different ways. First of all, using Terraform directly from Azure Cloud Shell. So again, the only little piece of software you need is Terraform.exe on a Windows, but it's platform independent, so you could download the Terraform bits for macOS, for Linux, but it's also natively integrated in Cloud Shell. And the benefit there is that it's always up to date, so you don't have to worry about versioning, and you don't have to wait for the initial download of the Azure resource provider once you run the Terraform init. The other nice thing is that you can combine ARM template deployment with Terraform deployment, because Terraform has a specific syntax, a specific parameter if you want, to recognize an ARM template. So the mindset they're using here is that customers most probably have been using ARM templates for quite a while. Then they discover Terraform and hopefully start using Terraform from there. But then you might end up in two different worlds, where maybe developers go for Terraform or any other team already using Terraform. And option one is recreating all your ARM templates and turning them over in a Terraform template, or maybe in the first few weeks, months, or continuously, doesn't matter, you can combine ARM syntax in a Terraform file. And I'll show you what it looks like. So the first part is similar to my previous examples. So this is where you specify in Terraform language what you want to create. So here we're creating a resource group, where the second part is targeting the Azure RM platform and running a template deployment. So this is really the same concept as going into your Azure portal, create new resource and searching for template deployment and then importing your template. And then on line 10, that's where you specify the template body. So I'm using this obviously for ARM, but and again, the multi-cloud concept, if you have a CloudFormation template, you could also mix the same. I never tried mixing Terraform language with ARM templates, and CloudFormation template language would be quite awesome, but never really tried it. But from line 11 all the way down to line 65, and I lost my mouse cursor again, that's literally a full ARM template JSON file, where next you can end up back into Terraform language and even making changes to the settings from your ARM deployment. So in this example, it's creating a storage account and virtual network and some other components, where the storage account is using local LRS, and the deployment is going to run. And then all the way when the ARM template snippet deployment is finished, it's going back to Terraform and modifying the storage account type to standard GRS, for example. So you could even override the settings from previous deployment steps you running during the same deployment. And then similar to ARM output, you could also have an output like storing IP addresses storage account names and anything in your on-screen definition. So the idea is that you're going to build up your template file. So mixing Terraform syntax, Terraform language with ARM template language. And from there, you go through init, plan, deploy again, and producing the same output. And that's where the Terraform import again comes in handy. The other thing that I didn't mention yet inside your Terraform or template folders is that you can store multiple template files, and it's going to loop through all of them. So a little bit reusing the concept of nested templates that we have in ARM, where you're going to create a main template file, and from there pointing to other Terraform files in the same folder or a different location would also work. And allowing you to come up with a scenario where the network team is creating the network.tf, the storage team is creating the storage.tf, the sysadmins are creating the virtual machine.tf, and so on, and then running all snippets during the same deployment. So from here back to my console where it failed because it's not recognizing my Linux SSH public key. So probably something wrong with the password, but not going to worry too much about it. I can see based on the previous steps that all other resources were deployed fine. So from here, I could first of all run Terraform destroy, and that's going to nicely clean it up, but I'll do that later on myself. So the last example is Terraform init and pointing to that mixed Terraform ARM template. So the first step is still the same. For next in the planning state, it's going to tell me that it's not supported anymore. Now what's important, similar to Azure ARM template APIs, where before I told you we're using a specific version. So Terraform by itself, like the Terraform exe, comes with different versions. I'm still using an old one because otherwise I couldn't show you the demos, but I'm using version 11, where the newer one actually released this week, but I'll talk about it at the end. They moved up to version 13, so I'm like 2 versions behind. And obviously the newer intelligence is also requiring newer Terraform version. So you could have older template files that might not be recognized anymore. And that's where at the beginning of a template file and during the init state, it's actually validating what resource provider version do you want me to use. And if you got older templates, you might need to go back to a lower version. But it's at least telling you up front and not while you try to kick off the deployment and figuring out or finding out that it's actually not working anymore. And even there, if you have, like in my case, I'm using Terraform in my C root. If I would create a folder called Terraform 13, and in there storing the Terraform 13.exe, then it could run fine. So you can easily mix and match. That's another benefit. And the last angle was Terraform in DevOps, because what I showed you up till now is all quite manual. So you need to go through Terraform init, Terraform plan, Terraform apply, and it's all command line based. So where it becomes interesting is end-to-end automation. And out of Azure, obviously, it means we end up with Azure DevOps. So what you're going to do is creating a pipeline in which you're going to run the exact 3 steps. And if you want, adding the auto-approve step setting in the apply, and that's automatically kicking it off. So I got a screenshot, but I'll try to open my DevOps environment later on. And even for customers, if they come back with a question like, yeah, but we already have this pipelines in place using Azure DevOps or Jenkins or some other DevOps tool, Terraform is just an additional step into the full story. So from here, if they've been using ARM templates, if they've been using Ansible or any other automation tool to deploy Azure backends or multi-cloud backends, Terraform is just gluing into it and you don't have to change anything. So from here, you could use yeah, I showed you Visual Studio Code. There's a extension for Terraform that's going to help you with IntelliSense for the syntax. If you have Visual Studio, there's no plugin as far as I know to do that, but you could reuse that information and from there running it through your pipeline deployment. And showing you, maybe using the correct browser would help. So from here, you build up your release pipeline. So that's firing off the actual deployment based on a couple of different steps. And technically, but that's just DevOps concepts where you could mix all the different manual steps together. So the first example here is running Azure CLI to create a resource group. And you already know from my demo scripts before that, technically this could be done by Terraform itself. And then using another PowerShell script to, for example, pick up the storage access key from the CLI deployment and using the token inside the Terraform file in this next step. Next, I'm going to install Terraform. And again, this is a little bit Azure DevOps specific, but Azure DevOps is using what they call build servers. So it's like a pool of virtual machines running on Azure already. And for each and every deployment, you just get one of those machines allocated. You don't have to build them yourself, although that's an option. And obviously, the build server is a quite generic Windows machine, Linux machine, or Mac OS machine. And if you want to instruct your pipeline to use Terraform, the build agent in the backend obviously needs to know that. So even here, you could emphasize the version. So remember that my version 0.11 is failing for the mixed Terraform language with ARM template language. And that's where here you could move up to a newer version. So just defining Terraform 12. If I want, I could go in here and change it to Terraform 0.11, and that would download the older version on the build agent. And then running Terraform init plan apply, similar to what I showed you in the console, and adding the auto approve argument into it to not ask me for that final confirmation. And then the last part, it's back to Azure DevOps, where we're running a task to deploy actual web app content. So we create a web app instance with Terraform and injecting the source code using another Azure DevOps step. The other nice thing is source control for the template files itself, because right now I'm using them on my local machine, which is fine because I'm the only one using it. But if I have like a larger team, multiple developers, multiple sysadmins using Terraform, then you might use a decent source control landing page. And within Azure DevOps, that could be Azure repos. So it's a little bit similar to like Git and GitHub Enterprise or public GitHub if you're familiar with that one. So just having a storage location, including versioning recognition for your template files. So in here, I got my web application inside the source. And within, I also define a Terraform folder, and that's where I store my terraform.tf, where I'm going to target the Terraform version and the storage definition, Azure RM provider definition, similar to my other examples. Where now if I make changes to this file, then it's going to keep track of the changes, and I got multiple developers working on it with branching, committing, everything that you have in a full DevOps scenario. Terraform as part of your Azure DevOps or broader DevOps tools that you're using. But one last part is using Terraform in Cloud Shell. So you don't need to install anything. It's always grabbing the last newest updated version. So if you need to go back to the older one, you need to specify that in your template file. So what I did from here is just uploading my Terraform deploy. And from here, you could just run it. So the exact same way as before. So all the different Terraform commands are available here, similar to what's available on my local machine. So from here, it would again be Terraform init. And so that was pretty much it. So first of all, I hope you enjoyed it, and I wish you a fine, nice rest of the day.